Hi, and welcome to another VANTIQ video. In this video, we show you some exciting new features of VANTIQ, the application development platform for building event-driven systems. And today we're going to show you the app modeler. And the app modeler is a way to bridge the gap between the requirements gathering of an event-driven application and the actual implementation of the application itself. So let's get right into it. We've got a couple of assets that are already created just to save on time a little bit. And the only assets I've got here is I've got some persistent data storage. I've got a persistent table, or what we call a type, called pumps. So I'm keeping track of ID and location. So the ID of the pump and the location of the pump. And then I've got some technicians. I'm keeping track of the technician's ID, the technician's phone number, and the location of the technician. We'll get that location from our technician's mobile device. I've also got a client. We're just going to use this for notifying the technician. So it's an empty client. Haven't done anything with it. And a simple procedure that uses a source called Twilio that sends a text message by taking the technician's ID, taking the message that we want to send to the technician, and then looking up the technician's phone number and then sending that out. In fact, if I were to run that right now, and you can see I've got my tech ID and the message string in there. If I were to go ahead and click on execute, then what you'll see is if I toggle over to my mobile device, you see that on the mobile device, you now see the text message that says, "Hello world," as we've done. But let's go ahead and start with our requirements gathering session. So I'm going to go ahead and we'll go to a new project, and I'm going to call the project requirements. And now that I've got my project, I'll go ahead and come to our add menu, click on new app model, and let's just call this pump requirements, or what I'll call pump recs. Okay, so now what you see is on the canvas, we've got our pump recs model, and you see these little sticky notes. And these sticky notes essentially represent different kinds of actions that occur in our requirements gathering session. In fact, the app modeler was inspired by event storming. The idea behind event storming is that it's an architectural requirements gathering methodology that uses sticky notes of different colors to represent parts of a system. And what you do in event storming is you gather key stakeholders, domain experts, engineers, and so forth, gather them in a room, and then you use the walls of that room in which to identify the application's requirements. Here we're going to do that electronically on the canvas. And so what I'll do is I'm just going to expand this out a drop. And this is a collaborative environment as well. And so one of the things that we'll see as we continue on is that we will have a number of individuals who can actually work on this model at the exact same moment in time. So let's start off with our first one. We'll drag the pink sticky note, which represents external systems, onto the canvas. Now, another thing, if I kind of show the window behind my screen and I log in as a different user, and then for that user, we look at the exact same project, you'll notice that when we look at both of these screens together, whatever I do on one screen happens on the other. If I drag an event onto the canvas, if I drag a reaction onto the canvas, it happens on both screens. And so in this fashion, we can collaborate with multiple individuals, not only in a given room, but across any number of geographic locations. We can truly do a sort of distributed requirements gathering session. So let's go ahead and take a look at the system that we're going to build today. So we'll go ahead and start by identifying what our external system is. Well, we're going to kind of model this after maybe some of the pump demos that you've seen on our website in the past. And so I'll say that this external system is our actual pump in this particular case. Now, typically what happens is external systems or other systems drive events. An event represents something that happens. It's typically written in the past tense. And then reactions are things that you do when interesting events occur. So you can think of events and reactions as if this, then that. When this happens, do this. All right, so let's go ahead and define our first event. And we know we've got a pump, and our pump is sending data. I'll just say the pump data is sent. Now, the next thing that's going to occur is we are going to react to that pump data being sent by identifying something that we want to do. And the thing that we want to do here is see if that pump data is over some thresholds. So I'll go ahead and define that as well. I'll just type, the pump is over threshold. Now we can also use some of the other note patterns like the issue to either represent issues, areas of concerns, or in this case, I'm just going to use these as comments. And so this one, I'm just going to say pump sends RPMs and temperature. The dialogues that you're seeing pop up, the autocompletes are just my browser cache remembering that I've done this in the past, which obviously saves on time in demo land here. So pump sends RPMs and temperature. And let's go ahead and put one more on the canvas. Let's actually identify what those thresholds are. So I'll say temperature, if the temperature is greater than 200 and the RPMs are greater than 4,000. So the idea being that as we build up this collection of requirements, anybody can come in and understand the various, what the domain scope is, what the events are that come into the system, and what behaviors are driven from this. And so our engineers, our domain experts, our business users, they can all essentially collaborate together. So let's go ahead and spend a little more time on this. We'll go ahead and add another reaction. So if the pump does go over thresholds, then what are we going to do? Well, that's going to drive another reaction. In this particular case, what I want to do is we're going to do a traditional service assignment. What we're going to do is we're going to find the closest technician based on their proximity to the pump, assuming that we know the technician's location on the planet. And then we'll go ahead and once we find that technician, we'll go ahead and say that they should be assigned. When we've found the technician, they should actually get assigned to the problem. And so all we're doing is building out in very plain English this business logic that encapsulates what happens when we get some anomalous readings from the data coming in from these pumps. Obviously, pumps have more than just temperature and RPMs, but for simplicity, we'll just deal with these two particular values. So what are we going to do after we assign the technician? Well, there's a few things we might want to do. We might want to notify the technician of the problem. So we'll go ahead and identify that as well. I'll say notify the technician of the problem. And I'll even go ahead and put a sticky note here, an issue note, that basically says that I want to use the mobile device to notify the technician. In addition to notifying the technician, once they're assigned, I might want to get a sense of where they are. Perhaps I'm going to calculate how far they are from the location, when they might arrive, and so forth. But for the time being, let's go ahead and simply say that we're going to do some location tracking of our technician. And when our technician actually arrives, in other words, when they actually get within the proximity of the location itself, we'll just go ahead and send them a text message that lets them know that they're in the general vicinity, they're in the correct area. And let's go ahead and decorate that with the fact that we want to use a text message to do that so that it's nice and understandable for anybody who's involved. All right, so now if you look, we have created our application model that has identified the requirements of our system. Anybody can walk up to this and say, I've got a pump. It sends data. If the data that the pump sends happens to exceed the 204,000 thresholds for temperature and RPMs, then I'll want to identify the closest technician. I'll assign that technician. I'll use the mobile platform. I'll use a mobile notification to notify the technician of the problem. And I'll start tracking the technician's location on the planet. And when they arrive, we'll let them know via a text message. So there's our simple requirements gathering session complete. Now what I'm going to show you is how the VANTIQ development engineers can now take this requirements model and create the beginnings of their application. So I'm going to switch from model mode to generate mode. And what I'll need to do in order to generate something from this is I'll have to group the various elements that I want to generate an application for. So I'll call this the pump app. And then what I'm going to do is I'm going to select a number of these items. Just hold down Shift and select them all in this particular case. And then we'll go ahead and add them all to the group. You see that they light up, so we now know that these are all part of that group. Now that I'm in the generate mode, and I've moved from model to generate, I can use my VANTIQ engineering expertise to start defining how these things are actually going to occur in the system. So if I open up the pump data, now you see I've got some additional options. And I'll say that this comes in from a topic, right? It could come in from a source like MQTT or a Kafka stream. It could have been a direct insert into the database, or in this particular case, I'll choose a topic. And the topic that I'm going to choose is /pump data. That's the topic that our pumps are emitting the data stream on. Now I'm going to connect that up to our pump is over thresholds reaction. And in this particular case, that's going to be an application task. Applications represent sensing and analyzing a situation of interest. And what we're going to do is we're going to be using one of our out-of-the-box activity patterns called threshold. If I wanted to do something custom, I could run a procedure or talk to some third-party machine learning source, whatever that happens to be. I'm going to use a simple threshold in this particular case. And then if we cross the threshold, well, now we're going to move from sensing and analyzing to collaborating. What are the things that we need to do in which to triage this particular situation? So I'll open this up and I'll choose a collaboration task. And since this is finding a closest technician, I'm going to use one of our out-of-the-box activity patterns called recommendation. This is a generic pattern. You can use it for any kind of recommendation. I'm going to use it for finding the closest technician. From there, I'll go ahead and we'll choose an assignment pattern that assigns the closest technician. And so what we'll do is we'll choose an assignment activity pattern. What this does is it simply assigns whatever we found in the find closest technician recommendation. We'll assign that user or that user's ID to this so that we can reference it easy. And then we'll go ahead and we'll do the notification. So the notification represents, as we can see by the note here, the issue note here, use the mobile device to notify the technician. So we'll use a collaboration task that uses a notification pattern. This could use the VANTIQ mobile app or it could use a custom mobile app. Doesn't really matter in this particular case. And then we'll also go ahead and set up our location tracking. We'll use the individual's mobile phone to track their location. So we'll use a collaboration task for location tracking. And then the last thing that we were going to do is when they got within close proximity, we were going to set up a reaction, which was to actually send them a text message. And I don't have a text message pattern, so I'll use a custom execute pattern, and we'll use that send text message procedure that we looked at the very beginning of the video. All right, so now that I've gone ahead and I've defined that, I can click on the generate button, which generates about 70% of this particular application. And we'll just have to fill in a few last things. So let's go ahead and click on generate. You see that the system comes back. It says the project pump app has been successfully generated from the app model. Switch to that project using the projects menu. So what has been automatically added here is that there is now a pump application. So we switch over to our pump app and we see that we've got our app and we see that we've got our collaborative activity. So we've got our application, which shows us the sense analyze part of our application. And we've got our collaboration, which shows us all of the activities that we're going to do once we identify our situation of interest. All right, so let's see what still needs to be configured. Our pump data looks like it's configured pretty well. It comes in on a topic called /pump data. And then we're going to check the thresholds with our pump over thresholds activity pattern, our threshold activity pattern. So I'll go ahead and say, what is the condition? Well, if you remember from the screen behind, we know that event.temp will be greater than 200 and event.rpms will be greater than 4,000. The direction, do we care when it crosses the threshold or when it goes back under the threshold? We only care when it crosses, so the direction will be forward or true. We'll group it by the ID. So the event stream that's coming into the platform will contain an ID. And we'll say that not one anomalous reading, but over 3 consecutive readings where the temperature and RPMs exceed these values, that will trigger our threshold, if you will. Then let's look at our find closest tech based on proximity to the pump. We'll configure that. Well, we're going to be associating this with an actual pump. So I'll choose the pumps entity type or the pumps table. And what is the constraint? Well, what we want to match is the pumps ID with the incoming ID from the incoming stream, which would be event.id. And with that, once I go ahead and click on save, I now have a fully working application that senses and analyzes for a situation of interest. So as you watch the screen for the next couple of moments, what you'll see is that once the pump actually exceeds those thresholds, it will trigger the threshold event and it will go ahead and try to start the collaboration. We haven't finished the collaboration yet, but we have completed the application. And so hopefully you've got a good sense of how you can very quickly move from application requirements design into application development itself using the VANTIQ application platform for developing event-driven systems. Now, if you want to stick around for a few more minutes, we'll go ahead and we'll actually connect up the rest of this application. In our collaboration, we've got a few things that we've got to identify. One is what entities, what tables are we going to reference? Well, we know we're going to reference the pumps table, so I'll go ahead and do that. And I'm going to reference it with a variable name called pump. So I'll put the pump in the singular. We also know that we're going to assign this to a technician. And so that'll be a collaborator. So I'll add a variable called tech to this. And so whenever we're going to reference our tech, we'll just be able to use that tech variable, if you will. Now that we've done those two things, let's go ahead and take a look at our initiate activity pattern. Our initiate activity pattern basically says whenever that situation is created, if we trigger the threshold multiple times, we don't open up new issues. We only open up a single issue for a given pump that is malfunctioning. Now we move to the find closest tech based on proximity activity pattern. And so what are we looking for? We want to find a technician. And we could specify match directives like how many technicians do we want to find. I'll take the default, which is I'm not going to specify any, but I'm only interested in the first one. Whoever the first person we find is, that's who we're going to assign. And the recommendation procedure. We're going to use various attributes of the type, or are we just going to use location? So I'll use location, the nearby recommendations procedure that comes out of the box. And I'll go ahead and click on OK to its configuration. Now, the runtime parameter is what are we passing into our recommendation engine? Well, to find the closest technician, we know we're looking for a technician, we have to pass in the pump's location. And so we'll do that by just basically saying that we're going to pass in the location of our pump. So now I'll go ahead and move on to the next activity pattern, which is our assignment. So if we look at the recommendation pattern, the result is an array, and we only care about the first item in the array. So I'll click on the assignment, and we'll configure it by saying we're going to assign it to our tech role, which is a collaborator role. And the parameter, who we're going to assign, is the results of the recommendation. And so I'll choose the results, find closest tech based on proximity, .recommendations. I want just the first one, so that's just the first item in the array. And I'm going to associate with it the tech's ID, which is their username or their user ID. Now we'll move down to notify the technician of the problem. And so we'll go into its configuration. The title of our notification will be pump issue. And the body will be problem with pump, and then we'll put in the pump's ID. So we can use pump.id in this particular case. And the client is that empty client that I showed you from earlier. It's just an empty client called tech notification. That way we just get our simple notification. And then we'll specify the runtime parameter, which is who is getting the notification. Well, it's the person that we assigned to this. So we'll just go into our list and say we want to notify our tech. And that's all we need to do there. We also have the location tracking pattern. There are a number of configurable parameters such as accuracy, the destination radius, how close do you have to be, the distance filter. I'm going to leave these empty and just take the defaults in this particular case. But there's a few other things we want to know. We want to know who are we tracking? Well, it's kind of the same. We are tracking the tech. So I'll go ahead and put in the tech there. That's who we're tracking. And where are we tracking them to? Well, we're tracking them to the pump's location. And we'll click on OK. And then finally, what we're going to do is we're going to send that text message. And the way we'll do that is we'll identify the procedure send text message. So there's our little custom send text message procedure, that little two-liner. And the runtime parameters for that, if you recall, are the technician's ID. So we'll go ahead and put in tech again. And some string, which we could use an expression for, but in this case, we're just going to say, you have arrived. And we'll click on OK. Now, when we hit save, we have now completed both the application generation for sensing and analyzing for situation of interest, and we've completed our collaborative tasks for what we're going to do when we find that, which is to assign a technician, notify them, and do the location tracking. So we'll hold on here for just another moment as we go over those thresholds. And we'll show you on the mobile device exactly what happens when we cross that threshold. And so here you see that we've got the pump went over the threshold again. You see that it initiated the collaboration. And if you look at the cell phone, we've got both things because I happen to be in the same location as the pump. We've got the arrival notice and we've got the mobile notification which says there's a problem with pump A12345. This has been a complete application development from requirements gathering all the way out to a finished product in just a couple of minutes. Hopefully you see just how powerful the VANTIQ application platform is, that ability to use multiple stakeholders, gather requirements from business users, from domain experts, from development engineers, and take that and turn it into a running event-driven application. Thanks for watching.